Okay, dear students, now let's continue. Now coming, the one is the fifth question, and it says the equation of a plane containing the point 1, 2, minus 2 and perpendicular to the line L, x minus 1 over 2 equals y plus 4 over 3 equals z minus 2. So here you are asked to find the equation of the plane, and the symmetric equation of the line is given. And one point lying on the plane is also given, 1, 2, minus 2. So how can you determine now the equation of the plane? Dear students, you need to know here one thing. If you see the denominators here, look, in the first case 2, the second one 3, and the third one 1, even though it's not written, it's understood. See, these numbers 2, 3, and 1 represent the components of a vector, directing vector of this line, okay? So the line is supposed to be parallel to the vector having components 2, 3, 1. So here, if the line is perpendicular to the plane, or if the plane is perpendicular to the line, as long as the directing vector is parallel to the line, again the directing vector is going to be perpendicular to the plane. So what you need to do here is, you see the directing vector, the vector with components 2, 3, 1 is considered to be the normal vector to the plane. So if you are given a normal vector to the plane and a point lying on the plane, it's very simple to determine the equation of the plane then after, because it's a matter of applying a times x minus x naught plus b times y minus y naught plus c times z minus z naught equals 0. Now you can consider ABC to be these numbers 2, 3, and 1, because these are components of the normal vector, whereas these points, this point 1, 2, minus 2, you see is a point lying on the plane, so you can consider x naught to be 1, y naught to be 2, and z naught to be minus 2. So using this into account, you can directly go to what? The following one. So look, if the plane is perpendicular to the line, then the directing vector of the line with components 2, 3, 1 is normal to the plane. So from this, we are going to have this equation directly used from the obtained formula. Look, the components are of the vector are already written here: 2, 3, 1. Even though it's not written, there is 1 here. Then x minus 1, because you are going to use x minus x naught. Here your x naught is 1. Y minus y naught, because your y naught is 2 here. And z minus z naught, because your z naught is minus 2. And here z minus minus 2 is going to be z plus 2. If you see the coefficients 2, 3, 1, all are taken from the components of the directing vector. Now students, if you if you simplify this, you will finally come across with the equation of the plane. And this is 2x minus 2 plus 3y minus 6 plus z plus 2 equals 0. So try to add those numbers together, and then you can have 2x plus 3y plus z minus 6 equals 0. And I hope this is available in the given multiple choice item. This is minus 2 minus 6 minus 8, minus 8 plus 2 is minus 6. So, and moving this minus 6 to the right, you could have 2x plus 3y plus z is equal to 6. And this is available here in A, so the answer for this is going to be A. And having this into account, what comes next is question number 6. So when we go to question number 6, we are having this one. It says given an expression an equation y is equal to cot inverse of tan x cubed, then here you are asked to find the derivative of y with respect to x at x equals 0. So this is very simple. What you need to do is you need to recall the derivative of inverse function. And we know that the derivative of cot inverse is negative 1 over 1 plus x squared. And using chain rule, we can directly find the derivative of this one in a simple form as follows. Look here. The derivative of y with respect to x here is going to be the d by dx of cot inverse tan x cubed. So clearly, as can be shown, you are going to consider this as y because it's already given for you. Now what you need to do is you have to recall the derivative of cot inverse x. and in x you are going to use tan x cubed. So chain rule again must be used. So we know that the derivative of cot inverse x is negative 1 over 1 plus x squared. But in place of x squared, we need to put tan of x cubed, because in x we do have tan x cubed. So tan squared x cubed can come, and then we need to derive tan here, and we know that the derivative of tan is x squared, and then x squared x cubed follows, and finally the inner one here, x cubed, must be derived, and when you derive this x cubed, you do have 3x squared. So in general, the derivative of with respect to x makes this. No need of now simplifying this, because you are not supposed to find the derivative of with respect to x directly. Rather, you are asked to find the derivative of with respect to x at x equals 0. So what you need to do is you need to substitute 0 in place of x. So as you are substituting 0 in place of x, look here, this is tan squared 0, this is 0, but 0 plus 1 makes 1. And here, even though 6 squared 0 makes 1, because of having x outside here, 0 squared is 0, 0 times 3 is 0, so everything goes 0. 0 divided by 1 is 0. So the answer for this particular question, that is, dy by dx at x0 is going to be 0. And this is available in D there. So the answer for this is going to be what? D. So having this into account, what comes next is question number 7. So question number 7 is the last, I think the last question in the case of multiple choice item. So you are given this one, the integral of ln x dx, but here it is a definite integral because the lower limit is 1 and the upper limit is e. So here we do have these multiple choices, so how are you going to find that? What you need to do is like this. First, you have to remember integration by part. It is using integration by part that you can solve this one. So let u to be ln x, student. Let u to be ln x and dv to be dx, as you see. So if u is ln x, the derivative of u with respect to x would be 1 over x dx. And if dv is dx, then v comes to be x. So the integral of u dv is equal to uv minus integral of v du, as you know. This is integration by part. And from this one can obtain the following one. The integral of ln x dx is going to be, now you are having u times v, so your u is ln x and your v is x. So it will be x ln x minus the integral of v du, it says. So your v now is x, so you directly substitute that x here, and the du will be derivative of ln x, which actually is 1 over x dx. So this makes the following: x is cancelled by x, and the integral of dx is going to come. So from this, the following can come: x ln x minus x. So had you been asked to find the integral alone, this could have been the final solution after having plus a certain constant c. But this is a definite integral, so it requires, you see, substitution of the lower and the upper limit integral values. So what we need to do is the following one. The integral from 1 to e of ln x dx now is going to be, first we need to substitute e in place of x throughout. Here e ln e minus e must be used because we are having, as you see, a definite integral. And then we have to have minus here because of the rule of, you see, fundamental theorem of calculus. So you do have minus. And then you put 1 in place of x here. It will be 1 ln 1 minus 1. So as it can be shown here, the integral from 1 to e of ln x dx is going to be now e ln e minus e. You simply put e here. Then have minus here, then 1 ln 1 minus 1 can come. And we know that ln e is logarithm of e to the base e. And this makes 1. So e times 1 is e, and e minus e makes 0. So this is going to be 0, students. And we know also that ln 1 is 0. Ln 1 is 0 because logarithm of 1 to the base e is 0. So 0 times 1 is 0 again, and 0 minus 1 is minus 1. So what you are having now is the following, students. So this is going to be this one. You see, this is E minus E, because ln E is already 1. 1 times E is E. E minus E, as I told you, it is 0 minus. Here we are having ln 1, 0 again. 0 minus 1 is minus 1. So as you see, 0 minus minus 1 is going to be obtained. And this makes 1. So the answer for this is going to be C, because it is already written under item C.